It's a real honor to be with you today, and I'm very happy to participate in this session. The previous authors have mostly discussed with a lot of passion about exporting, routes of exportation, and economics. And as we say in French, il faut faire attention de ne pas vendre la peau de l'ours avant de l'avoir tué. That means it's very important when talking about the roadmap to clarify the ideas about what we have at stake, what's in the underground, what's the resources. And the topic of the Levant Basin oil and gas resources has tremendously changed over the last few years. So what I'd like to do today with you is share some ideas about very simple things. One, what do we know? Or what do we think we know? Second, what do we don't know? There are lots of things we don't know yet, so I'd like to outline what we don't know. And finally, lots of things we hope to know in the forthcoming future. An important remark is that whenever thinking about the potential of Lebanese offshore, we have to remind that there is no well drilled. So all the concepts, ideas are based on data acquired and interpretation made before drilling in Lebanon, and observations and facts and interpretations published and made available to the community in neighboring countries. So that's limiting our state of knowledge, definitely. On the other hand, we benefit from the good and past experience made by operators in the neighboring countries. One word about BCIP Lab. We are part of the IFP. BCIP Lab was founded 60 years ago. It's a large international independent consultancy organization. We are part of the French public sector company. As IFP, Institut Français du Pétrole et Énergie Nouvelle, is a public sector entity. There is the IFP school, which is well known, which trains the professionals in the oil and gas from the upstream, downstream. IFP has, as a research group, has been very much involved in Levantine Basin understanding. Not less than 5 PhDs doctora were developed over the last 6-7 years, all with Lebanese students, and there is one going on with, I believe, Université Saint-Joseph. So it shows the long-term commitment of the IFP as a research entity to the understanding of the offshore of Lebanon. We, as BCIP Lab, we offer our consultancy services to the governments, regulation agencies, operators worldwide, particularly in gas-producing countries. We are very active currently in Iran, in Qatar, in Russia, Bolivia, Latin America, big gas-producing country for South America. Part of our consultancy deals with regional assessment, so exploration, like what I'm going to talk today about the Levant Basin, but also field development. And 50% of our activity deals with field development and how to develop in the most technically and economically sound way the discovered oil fields. We also have a quite considerable downstream expertise. Right now, we help a big gas country, Turkmenistan, to elaborate a gas master plan. We are precisely doing what His Excellency, Mr. Al-Attiyah, was referring to, design the basket. Where should this country that has a lot of several hundred TCF non-developed gas reserves, where should they put their eggs? GTL, LNG, petrochemical, so we currently help them assess different petrochemical projects and look at the markets and also the best technology to produce those petrochemical products economically. Now, as far as the Levant Basin is concerned, our involvement as consultant has started on the Cyprus side in 2007. And in those early years, there was very little knowledge and no big discoveries made in the Levant Basin. And we have started helping the Cyprus authorities, assess the seismics, understand the petroleum system, understand the prospect. We mapped Zohr-type prospect on the Cyprus side before Zohr was discovered. We also had them on the economic and contractual side, and we bring some assistance in the licitation process. We have been involved with the Lebanese Petroleum Administration since 2011, and we have also brought our assistance in the evaluation of the subsurface technically, the geology, the resource, the petroleum gas systems. We also have brought some technical assistance for the economic modeling of petroleum contracts. So I want to thank very much the LPA for this very efficient cooperation and fruitful exchanges. A lot has been already said about the discoveries. A few facts. First, the exploration history of the Levant Basin is quite short. If we think of oil and gas provinces, in fact, the whole history has more or less started in the late 2000, 2009. So this is junior. This is very young baby. That's number one. Second, monsters were found in a relatively short period of time. At the world scale, those discoveries that you see on this map are very, very big world scale discoveries, and they came as a surprise. No one expected such big discoveries to be made in the early stage of exploration. Number three, relatively few wells have been drilled and were dry. There were some dry wells. Everyone speaks about the discoveries, which is fine, but there were also dry wells drilled, and we have learned a lot from the dry wells that were drilled. And 2 years ago, after discovery of Aphrodite, 2 dry wells were drilled offshore Cyprus, in this region. Yeah. Can you see? Yeah, in this region here. So we believe we can learn as much from the dry wells that are published, that are observed, than from the discoveries. And finally, the geological context is very complicated. We are here in a very small basin at the interaction between 4 plates. And I would like to outline a little bit this technical complexity just to give you a flavor. The Levantine Basin comprises 2 parts, the northern part offshore Lebanon, the southern part here, and is a mosaic between the northern plate here, Cyprus Arc, kind of submarine mountain. We have Lebanese, the Arabian plate. There is a small plate that detached away from the Arabian plate that marks the Eratosthene microcontinent here. And in the south, you have the huge Nile Delta, Africa. So due to this complexity, geologists are faced with a large complexity, sedimentology, sediment complexity, structural complexity. But the good news is that we have various sources of sediments, of sands, various source rock, positive thing, good cooking schist, and lots of structures. Structures are complex to map. There are lots of them, and we need structure. Any accumulation must correspond to a structure. So these green arrows represent the infilling of the sediments. The dominant view until recently was that most of the sediments came from the south, from the Nile. And this is, by some extent, not very good, because the more you get away from the Nile to the north, the less you have a probability to find sand. But recently, more and more, we see that there is other possible source of reservoirs, and the most prominent of which, with what a dramatic change, is the recognition that we have carbonate platform. Carbonates are found all around the Eratosthene block here, and all along the margin here. And virtually those carbonates, until the discovery of Zohr, were not considered as a priority objective. Now, after discovery of Zohr in those carbonates, the whole carbonate rim around the block in Cyprus, but also along the shore in Lebanon, becomes a #1 objective. Geologists also prove that besides the sediments in green, we have influx of sediments of sands from the north and from the east. And this is more favorable. It means we have more probability to find the sand in the deep reservoir. So in a nutshell, we know we have several reservoirs, and some of them are now very high priority targets, those carbonates, which were not considered as such interesting before the discovery of Zohr. This is a cross-section. It's seismics. To the right hand, you have Lebanon coast. To the left hand, you have the Eratosthene block, and in the middle, you have the basin. So we recognize in pink, the salt, and all what is of interest are below the salt. So I would like to outline what we know and what we don't know on this section. First of all, we know we have two source rocks. Source rocks is where the oil and gas is generated. We have two levels. The upper levels is clearly demonstrated and has fed most of the known accumulations in Israel. And the second source rock is now more and more considered, and there is ample regional evidence that this second source rock is also important. What's very unique to Levant Basin is the third source rock. And this third source rock is biogenic gas. It's very unique. There are very few basins in the world, maybe 4 or 5, where biologic activity in the rocks has created gas which has accumulated into commercial discoveries. This does not exist in the whole Middle East, in Africa. It doesn't exist in Latin America. It's very unique to this place. Some northern basins in Siberia have these characteristics as well. So we have a third source of gas. But this gas is different from the other ones. It's only C1, methane. And our models, our interpretations, our cooperation with LPA very much suggested that the expected gas accumulations that we can find in the Levantine Basin will be a mixture of both the two deep source rocks and the biogenic gas. So we have 3 chances to feed the structures with oil and gas, with a heavy biogenic component. Then we need reservoirs. Where are the reservoirs? The well-known reservoirs in the region are what is called here Miocene sands. They correspond to those reflectors. This is very well known. The whole productions from Israel and reserves comes from these Miocene sands. But now, since Zohr, we see a potential for these carbonates I mentioned before. You see those carbonates here on the margin of Lebanon. You also see them on the other side on this block, on the other side, on the Cyprus side. So you see here that I will have a detail on this later on, but we have an obvious exploration target associated with the sandstone which prevail in Israel and those carbonates which prevail at Zohr. But we have a third reservoir unit, which is not known very well, but that shows up very well on the seismics, which these lower Cretaceous sands, those deep sands. These deep sands have never been drilled in the Levantine Basin. Today, we don't know. We know they exist, but we don't know their potential. The good news is that those sands will be drilled this year on the Israel side in the Leviathan, I believe. The company has announced they will have a deeper well, and therefore it will be very important to watch and to see what they will find, what the company will find when they drill for the first time these deeper reservoirs. But in a nutshell, we have 3 source rocks, including the biogenic, and we have 3 good reservoir candidates. And we have structures. The structures are all these little bumps that you can see here, all these faults. There is a lot of structures. And these arrows represent the expected migration route. The oil and gas will come from the source rock and will progressively migrate and accumulate in the reservoirs. So we have spent jointly with LPA a lot of effort to understand the risk of this migration, and how this migration can lead to commercial accumulations. This is an interesting zoom that compares this carbonate offshore Lebanon with the carbonate of Zohr. It's the same vertical and horizontal scale. And you have here the gas contact at Zohr. So you see it's 600 meters gas column. And you see that the size of discovery compares roughly, of course there are differences, but it compares roughly with the size of the carbonate bodies that are recognized offshore Lebanon. So interestingly, of course, this suggests the questions, okay, what happens if one drills these carbonates? In terms of structures, I mentioned before that due to the situation of the basin, we have a large variety of faults, all kinds of structures and faults. So structures will not be a problem. There are lots of structures. Seismics also, before drilling, suggest we have sense. It is possible with advanced techniques to use seismic data to try to understand the rock that has contributed to the reflection. And this type of work has been done in pilot area and very evidently shows that there are sandstone. Although this has never been drilled, clearly we can see that we see sandstone in the deep part of the basin. So that's a direct evidence or indirect evidence using seismics of what drillers can expect after they put some well here. This is the upper reservoir, the Miocene reservoir. And finally, we have some evidence, like here, where you see a structure, and the seismic data clearly shows the presence of gas. We most probably here see what we call a gas-water contact, something horizontal here, and maybe a gas chimney on the top. So there are observations like this one, which show that there is gas. It's a direct observation of gas on the seismics. Finally, models, numerical models, like this one developed by the IFP, which is used worldwide, help model through the geologic time the generation and migration of hydrocarbons. And on this section, on this 2D section, you can see the predicted occurrence of oil and gas today. And interestingly, what you see is that the model predicts pure gas in the pink, but in those reservoirs, a mixing of gas and condensate. Condensate is very high value, especially for petrochemical considerations. And even the model predicts on the margin the presence of oil, liquid hydrocarbons. So although the basin is quite deep, so therefore most of the hydrocarbons in the deep basin will be gas, still there are occurrences where you have upwards migration through faults, and we can expect condensate, and we can even expect liquids on those carbonates. So indeed, the margin remains a target for liquid oil, petroleum exploration. So this is a little detail of that shows that we have the green corresponds to the area where we can expect liquid hydrocarbons in the system. Now, in a nutshell, and to conclude, I would like to point out a few facts. First of all, seismic data of very high quality is available in Lebanon offshore. And from the point of view of the understanding of the basin before licitation, before the first drilling starts, probably the Lebanese offshore basin is one of the best studied in the world. So the data is there. The interpretations are there. And they are very encouraging. Many structures, many reservoirs, and models, oil and gas generation models that suggest indeed gas prospectivity, condensate prospectivity, and even on the margin, liquid hydrocarbon prospectivity. Now, I mentioned that it will be very important to watch what's going on in the next year to come in the neighborhood, because insights can be gained from this understanding. The first thing to watch is the deep drilling at Zohr. Eni is today drilling the carbonates I showed you. Is today starting to produce this carbonate, but they are drilling to reach a deeper carbonate. If this deeper carbonate is confirmed at Zohr, today we don't know, then that would augment significantly the prospectivity of the carbonates in Lebanon. Second, a licitation is currently underway in Cyprus, and the result will be announced very quickly, and more Zohr-type structures will be drilled on this circular carbonate rim. Total, other companies took blocks there, and there will be more knowledge, more drilling results available in a year from now from this additional drilling. Finally, remember this second deep reservoir I mentioned, the Cretaceous? That will be drilled this year, they announced, in Leviathan. So it will be very important to notice and to see what is found for these deeper reservoirs. Finally, I would like to say that planners in Lebanon have at their disposal, I think, a very unique set of data and interpretation. Of course, there is uncertainty, but there is a lot of data regarding prospect distribution, prospect size, NPVs, even production profiles, etc., which are, of course, of tremendous added value for planning purpose. If we now think of this basket in terms of LNG, in terms of export via pipelines, in terms of petrochemical industry, etc., it is very important to know what's the resource, what's the production profile, even what's to know what is the size of individual structures. Are we going to have few large structures or a lot of relatively smaller structures which will call for commingled production systems? So this is very important. But at least these interpretation exists to a very high level of sophistication, and I believe now it's a very good news that the dissertation takes place, and this will be now used to attract investors, and I'm sure this will be very successful. Thank you very much.